This is number 20 on the sample final. It's a heat problem. To make iced tea, how much ice should be added to 2.72 kilograms of hot tea at 93 degrees Celsius so that the final temperature is 0 degrees Celsius and no ice remains? Assume that the specific heat capacity of tea is the same as water, and you of course would use the enthalpy of fusion for water as well. So this problem has to be solved by saying that heat gained equals heat lost. The heat gain is going to be the Q from the ice, and the heat lost is going to be the heat from the tea. The heat gain from the ice is going to equal your mass times your delta H fusion for ice, or water in this case, and you're going to use mass of your tea times the specific heat capacity of the tea times your delta T, your change in temperature of your tea. So that's mass of ice. We're going to solve for our mass of ice. So we'll have your mass of T times your specific heat capacity of T times delta T of your T. This is all going to be divided by your delta H for fusion of ice. So if we solve for this, our mass of T is 2.72 kilograms. That should set off a bell in your head saying we don't want to be in kilograms. 1 kilogram equals 1,000 grams. Our specific heat capacity, we already said, is the same as water. So now we're in calories per gram. Our delta T, simply 93 degrees Celsius. We're going from 0 degrees to from 93 degrees to 0 degrees. So now we're out of Celsius, and our fusion value is 79.1 calories per gram. So if you're careful with your units, you end up with grams equals 3173 grams of ice. We are limited to 3 sig figs. No, 2 sig figs because of our temperature right here. So we'll express that as 3.2 times 10 to the 3 grams of ice. So that's a heck of a lot of ice you're going to add to it, but then again, you have a lot. You have almost 3 kilograms of tea to start with. So this is number 20 on the sample final.